Thank you so much for coming tonight. I'm hoping that you all at least take away one thing today. I just want to see a show of hands first, though. Who has done or is already a front-end engineer right now? Like, who's done some form of front-end engineering? Okay, cool. Who feels like they know lots and lots and lots about front-end web performance? You can probably all, like, leave, all of you. And who just, like, wants somewhere to get started with, or like some concepts to think about so they can go research them later? Okay, so the second group that just raised their hands, that's what I'm here to do tonight. So I'll talk about more about what I'm going to cover in a second, but Sergey already introduced me really well. But right now I am in developer relations at Microsoft, so I mostly talk about cloud stuff, Azure stuff, and IoT, which is another one of my specialties. So if you do want to come talk to me about that later, that's totally chill as well. I have had a very interesting sort of development past where I've done a whole number of different things. I'm a former front-end developer, and that's what I've done for most of my career. So I've worked at companies in America such as Kickstarter and Zappos. At Zappos, we were particularly obsessed with performance, so that's where I learned a lot of the stuff that I know now, and that's kind of what got me excited about performance. And back in Australia, I worked for a group of companies before moving to the US, including Australian government departments and places like that. So I have sort of watched the front-end performance landscape change over the last 13 years. As Sergey said, some things are still relevant, and you'll still find blog posts on the Perf Planet where it's still completely applicable, but we also sort of slightly changed focuses over the years, and we also get to adopt new tools that help us with performance. So I'm going to be covering a lot of sort of new APIs and stuff, as well as looking at what might be coming down the pipe in the future, and then looking at maybe why people aren't currently using some of the stuff that's readily available, such as web workers, which was covered a couple of years ago. So tonight's aim is to equip you with enough knowledge to feel like you're in control of the situation, where you can go to work and say, all right, I already have some ideas on how to profile things and maybe find things that I can fix really easily. So I'm trying to give you some low-hanging fruit. But a caveat, tonight is not a complete guide, but it is a good starting point. So as all of you are probably well aware, performance is a really deep topic. It's full of caveats and ifs and buts and what about this. So I've tried to generalize as much as possible so that you can actually go and find out whether these things apply to your work or not. So tonight we're going to be covering a myriad of different things to do with runtime performance, and even boot up performance is included in that. So anything after the page has already downloaded all the assets, that's where we're going to start. I'll also be talking about the tools you use to measure performance on the front end and what can help you look for bottlenecks, and also just some resources that I found useful when putting this talk together, and resources that you might also find useful. So the main focus today is actually going to be mostly on JavaScript. So we're not going to be talking about images, or we'll talk about CSS a little bit, where it can help us with performance, but we're mostly focusing on the things that we have control over in JavaScript, and the things we might be doing in JavaScript that's sort of getting in the way of performance. So why is this important in the first place? Why is runtime performance now such a hot topic? It always has been, but it is definitely more lately because of certain statistics changing. So this is from Statista, I don't know how to pronounce that, but this is the share of mobile internet traffic as of August 2017, so not that long ago. The gray bar, which is the third one down, is basically showing like the global mobile internet share to this time period. So the numbers are pretty small, so I'm sorry if you can't see that on the screen, but the global is at 52.64%. So what that's saying is more than half of the world's global internet traffic is actually coming from mobile phones and smartphones accessing the internet. So that's actually now overtaken desktop browsing, which is kind of a big deal. And when we think about that, we think about when desktop machines are accessed, they're like super high power. When people have mobile devices, particularly affordable devices, there are a lot of Android phones on the market that are very affordable and therefore don't have really fancy processes, we have to think about this much more seriously, given that that is now the greatest share of traffic. More people are accessing your website on their phone than on the desktop, so that's definitely a cause for concern if your site has some performance issues. Because we might all have computers like this, but we are not our users, right? I wish I had a setup like this. I would definitely not put graphs and stuff on there. I'd put way cooler stuff. But we're not talking about people that have these machines. Like, this is for us, the enthusiasts, but there's a lot more diversity in our users that are using our websites, and it's not this. It's a lot of the time they're on a train, they're trying to access something quickly before they go into a tunnel. It's a totally different experience to this. So let's start with how something like a mobile phone can really struggle with being able to run all of our websites on it. So a lot of you will be very familiar with this number here. It is 60 FPS. FPS stands for frames per second. Most devices, including most mobile phones, will refresh their screens at 60 Hertz. And browsers these days are modern, and they try and keep in sync with this. So they're trying to push an update to what you're looking at on your phone 60 times per second. And so that's a lot of work that these sites are doing, and this is sort of an introduction to where we can actually see Jank being introduced. So Jank, I like to sum it up, like this is a very abstract summary, but Jank is essentially a variable frame rate. So in a perfect world, we have the really nice 60 frames per second, which means that when people are scrolling with their device or using their mouse wheel or their keyboard to scroll, you know, you're still seeing everything on the screen update very responsively. People are clicking on things, and it's actually interactive, and things are not getting held up. So a variable frame rate is what Jank actually looks like. And jankfree.org, which is one of my favorite websites for finding out how to get rid of Jank, says it's any stuttering, juddering, or just plain halting that users see when a site or app isn't keeping up with the refresh rate. So the biggest challenge we have in the browser is that our UI thread that handles painting and reflowing and calculating also runs all of our JavaScript. So we have to like share that time, and this is essentially where most of our Jank actually comes through. We're actually being a little too greedy with that, and we're not letting the browser actually do the other stuff that it's trying to juggle at the same time. So let's kind of start with boot up performance, because this is obviously very near and dear to any performance enthusiast heart, because it deals with like not just downloading all the assets, but then what happens once you've got them downloaded? Like, will my website actually start showing all of those assets immediately? So this is from HTTP Archive in February 2017, so just a year ago. I picked out probably the largest assets that we see on websites. So on the left, the pie chart shows that we have 1,556 kilobytes of images. Video is actually only 175 kilobytes, which is actually pretty small a year ago. And then we've got scripts, which you can think of as JavaScript, at 386 kilobytes. So this is what it's actually downloading. It's not like gzipped or anything like that. Then we're looking at average bytes per page. In February this year, images have jumped up another 300 kilobytes almost. Video has gone up massively, like almost an entire megabyte. And scripts video was really scary, by the way. I was like, wow, that's a lot more. And scripts have still gone up quite dramatically, like having 32. I'm really bad at math. I just had half a beer. That is still a solid jump in size. And so, I'm sort of choosing to focus on this for one particular reason. And that's because you can say to me, yeah, but Suz, like, people aren't downloading like 500 kilobytes of scripts. Like, I'm gzipping them, I'm minifying them, I'm doing the right thing, like, it's very chill. Yes, but that's awesome. But when it actually obviously like decompresses that on the other end, it still actually needs to execute that code. So you can have it come down really quick, but the browser is still obviously going to be like, oh my God, this is a lot. Okay, give me a sec. I've got to open this, look at it, compile it, execute it, evaluate it. So this here is like a truncated like profile that I did using Chrome DevTools. This is on a website that I actually used to work on before I became a developer advocate. So it's sort of like the last like relevant profiling or the last relevant site that I worked on to do with perf. And you can see here that there are some scripts that are actually just put in script tags in the HTML. So that's where we have evaluate script tucked inside our pass HTML performance timing. And then we have evaluate script, which are the other scripts that it's pulling down, which are external scripts. So when you look at all of this here and you do the math, this here it actually equates to about 1.2 seconds before your script actually starts like officially running, right? So it takes 1.2 seconds from when it's downloaded those scripts. It's downloaded the HTML file and starts showing it before it's actually going to start running your stuff. And 1.2 seconds of someone on their phone or someone who is like just trying to either scroll or just see what's interactive, if it's got a lot of that stuff to pass, that's when it can actually lock up the UI thread while it's doing that. So that can be really frustrating. And I did this profile on this computer, and this computer is only a year old, and it's like full spec 2013 MacBook Pro because I'm a Twitch streamer and I need like the biggest deck I can get from this pathetic laptop. And so imagine this on a mobile phone. This would be seconds and seconds, right? Because this machine is actually really quite fast. So this is a problem. Like, we should be able to solve this, and maybe we can still have it take the same amount of time, but how can we actually get the site at an interactive level faster than this, you know? And we can look at kind of the obvious, which is, do we need all of this JavaScript to start running immediately after it's downloaded? So there's a pattern that the Polymer team at Google originally came up with. I know that Adi Osmani has done a few presentations on it, including at JSConf EU last year and also Chrome Developer Summit last year. And it's called the purple pattern, so that's how you pronounce it. It's PRPL. And this is a really nice way to remember this. It's push, render, pre-cache, and lazy load. So you push critical resources for the initial route. So let's say someone's going to the home page. You're going to want to like just push the stuff that someone needs to use the just the home page, like the bare minimum that you need to get started. And I can show you some examples of this in the next slide. Then you render that initial route so that they can actually start like interacting, scrolling, reading it. Stuff actually turns up on the page and is clickable. Then you pre-cache the remaining routes later on. That way, when they go to the next route, it's actually already kind of like compiled and evaluated that, and it's ready to go with that too. So then subsequent page loads, especially if it's a single page application, is just going to be like way quicker. Then you lazy load and create your remaining routes on demand as you think that they're going to need to be executed. So I got this again from developers.google.com. It's along the bottom, but I'm also going to be sharing just the Web Fundamentals Performance URL later on as well. So let's look at an example, and I hope this is large enough for you to see. But I have an index.html, so this can be considered the homepage when someone goes to a website, such as Microsoft.com, Meetup.com, or Fastly.com. A lot of the time now, especially if you do a single page application, you're going to ship like one bundle.js, right? And that's going to contain the vendor code if you're still using jQuery, for example, or if you're using underscore or Lodash or anything like that. And that's going to come down as like one big chunk, but sometimes you have stuff in there that the homepage doesn't actually use. And so instead of having this pattern, what we want to look at is chunking, which a lot of common bundling libraries for JavaScript do these days. I know that Webpack does it. I'm pretty sure Parcel does it. There's a lot more out there that do it. Obviously, they do tree shaking too, which only will package the stuff that your code is actually touching, but that's a different topic. So what we can propose here is instead, we split this out to different pieces that are needed on demand. So maybe when someone loads the homepage of this website, they probably do need vendor.js, which has our Lodash or underscore and moment.js and all of our other libraries that we use. We might have a shared JS, which is a bunch of like resources and libraries we've written in-house that multiple routes actually share. We definitely want to split that out so that that's already loaded once and other pages subsequently can already make use of that cached resource. So that can be a really good thing to chunk out as well. And that's already executed and waiting. And then we can load stuff that's only needed for our index.html once it's already using the vendor and the shared stuff. So this is stuff that's unique to the homepage, such as the homepage has a carousel. So we're actually like kicking off that carousel, and we have a JSON list of images that it's using in the carousel and things like that. So that would be your bespoke JavaScript that doesn't belong in vendor or shared, right? Then, if somebody went to another page, such as About, or they went to a product page, if this was a retail site, or they went to their accounts, if they're logging in to update their credit card, they already have vendor.js and shared.js. That's all ready to go from the last page. And if it's a single-page application, that's already been evaluated and compiled, and all of those library assets is literally sitting there as objects waiting to be used in memory. And if they go to About or Product or Account, even if you are loading that stuff like on demand later, that's much less for it to download. So this could be the initial load for someone who goes to, it doesn't even have to be the home page. You can swap this around to be the product or the account. And then we can always wait until the user is either not interacting with the site or is doing something that's like less expensive than the whole website booting up. And that's when we can start lazy loading these other assets that either we know they're going to need, or maybe they're further down the page and they're kind of hydrating things that they're not even going to get a chance to get to yet. So we can definitely split this work up. It does take a lot of thought, but this is kind of the approach of Purple, of being able to kind of have that foresight into, we write the code so we know what each piece is doing, so we can intelligently split this up so that we don't have that 1.2 seconds. So essentially, this could be bundle.js right here, and we've split up the 1.2 seconds into much less time. And if anything, on some pages, because we might not even lazy load those routes, we've actually cut it down even more. So that's kind of like one solid thing you can do to make sure that once your assets are downloaded, your page boots as fast as possible. But once it's booted, like what kind of things do we see in runtime performance where we start seeing bottlenecks with the code once it's already running? So let's go back to our 60 frames per second again. Most devices refresh their screens at 60 hertz, and browsers try and keep in sync with this. So we're affected by a very similar thing to the boot up time, where we were using all of that existing frame time when someone's trying to scroll, where we're just executing all that JavaScript. So in this case, in our general UI thread, which I didn't cover before, one frame is doing a heck of a lot of work as it is. So we've got JavaScript, we've got style calculations, it's doing layout, so it's like calculating where stuff is. It's doing paint setup and then doing repaints, and it's also doing compositing. So it's kind of figuring out, okay, do these things now need to be in their own layer instead of being grouped with these other things? So it's just constantly reevaluating this page and figuring out how it can best kind of put stuff together to stay performant. And it's trying to do all of this and then run your JavaScript, which is the top of this list, all at the same time. And this works out. If you think about 60 frames per second, you only get 16 milliseconds per frame to retain that 60 frames per second performance. 16 milliseconds is not a lot of time to be able to do this. And so that's why we do see it taking so long for it to boot up our JavaScript. And when people are trying to scroll on their website, the whole thing is locked up. So we also contribute to this when the person is actually already starting to use our website. So another way to think of Jank is that work is starting to take longer than one frame. And like we actively contribute to this. Static websites don't very often have to do more work than that unless you have a lot of nested things in divs. But we're mostly talking about JavaScript today. So let's talk about what the expensive work is that it's doing in these 16 milliseconds at a time. The style calculations, the layout, or reflow as it's called in Firefox, the repaint, and the compositing. they're the things that take the most amount of time. These are the things that your code literally influences it doing as well. So the way that you write your HTML, your CSS, and your JavaScript affects how long and how often it has to do all of this work, right? So I'm going to go through a few examples of this, but again, it's not in depth. It doesn't cover everything. So we want to avoid causing the browser to have to, we want the browser to have to do as little of these as possible and not have to keep constantly doing them per frame. So one way we can do this is to use hardware-accelerated CSS. If we use JavaScript to animate things, that can actually start using up that UI thread, and it can start making it have to constantly start calculating things. So if we use hardware-accelerated CSS, the top version is not hardware-accelerated. So if you were to use those CSS properties in JavaScript, it would not be hardware-accelerated, and it can cause more paints on the screen to happen, and paints take time. And you will see that in your profiler, that any JavaScript animations where you're not using hardware-accelerated CSS properties will have these little green stripy paints that can slow down each frame. Lines 6 to 8 is the hardware-accelerated version of lines 1 to 4, sorry. So you can do a transform which uses the GPU, and it doesn't actually use the UI thread to be able to calculate that. So it's actually a lot faster. You're actually just pushing off your work to something that does a better job at that. Your browser is not going to do as good a job at moving stuff around and such as like animations as something like a GPU and CSS can. So that's one really small low-hanging fruit thing you can do, particularly if you're doing a lot of animations in JavaScript that you have control over. Another thing that happens super frequently, because JavaScript is actually quite performant these days, given that we have really performant engines, is that we stop sort of caching things that we don't really need to always have the latest version of. So in this case, I have a box which is just a div on a page. We're getting the element with a query selector. We're also grabbing, sorry, this should say query selector all. I apologize. I realize there's a bug there. But we're getting our paragraphs where it would be document.query selector all and then the paragraph tag. Then we have this function, and I know this is incredibly contrived, but we have a function where let's say the box for some reason is significant at a period of interaction. We want to loop through every single paragraph, and we want to set the width to be exactly the same as the offset width of that box. So let's say we're just adjusting that based on something that happened in our website. So this here, whenever you get the offset width, whenever you sort of do anything that's like geometric, so that doesn't mean like shadows and things that the browser would normally paint, but if it's trying to figure out the position of something or the size of something, this is going to trigger layout in the browser. It's basically going to go from scratch, and it's going to figure out the layout of the page in order to compute that offset width for you. It's going to basically say, if anything has changed on the page recently, I need to go start from scratch just to be able to fetch that offset width for you. So if you do this in a layout, if you do this, sorry, in a loop, it's going to go back from scratch and do a layout every single time. And that's one of the most expensive things you can do in a loop. Now, I'm calling this layout cycling, but it's actually more commonly known as layout thrashing. I just think thrashing is like a super intense word to use. It just has weird connotations, so I like to call it layout cycling. But essentially what you're doing is, this box.offset width is never ever changing with every single loop you're making, but you're asking for one of the most expensive things for the browser to do, and that's to figure out what the width is from scratch every single time. The reason why it asks for that every single time is that you're changing the width of the paragraphs. So you're basically invalidating that last layout that it did every single time because you changed one minor thing and the browser has to go back to the beginning. So a pretty simple way of doing this to fix this is the only added lines here are 4 and 5. The rest of the code is almost exactly the same. We are caching the offset width of the box, given that we're never changing that during the loop at all. Like, that's not anything that's ever going to change. So we're triggering layout once by just asking for that. Then we're looping through, and we're actually using that cached variable on line 9 to just change the width to this actual value that isn't having to go and recalculate every time. So this seems like a super trivial example, but imagine if you had several of these kind of things on the page where you're saying, well, JavaScript is fast, so I'm just going to ask for the offset width, and I'm not going to, like, you know, waste another variable or add an extra line of code. Like, my code's more succinct this way, and it's fine. But you may find that this sort of stuff is getting in the way of other things like scrolling and all sorts of other behaviors that's on your website. So that's one really quick, simple fix you can do. Have a look through to make sure that you're not constantly recalculating stuff, and your profile will actually let you know whether that's happening. And that's much nicer. Another thing you can do if you're creating JavaScript animations rather than CSS animations is you can schedule them with requestAnimation frame. So who's heard of requestAnimation frame? So in the old days, we did animations with things like set timeout or set interval, but set timeout and set interval don't really have like very precision timings. And it's also just a weird way to do it. So requestAnimation frame came out a long time ago. It's supported by all the major browsers. And what you can do is you can say, hey, when you're actually ready to repaint in the next frame, can you also run this code that I have? And so it's not only a much more accurate way of timing your animation so that you will get that 60 frames per second, but also it means that it will schedule that work when it's actually ready to in the first place. So we can have a look at an example of this where we're just getting an icon with a query selector. Could be just a little picture on the screen. We're starting the left position of that to be 0, and we have a function called update. Now, at the bottom on line 11, we're actually calling, we're passing that function in for requestAnimation frame to call. So what that happens is when it encounters that line, it's going to wait until the next frame, wait until it's ready to paint, and then it will actually run that function for you. So what the function does is it takes the left position as its current value. So the first time it runs, it would be 0. It adds 5 to that, and then it sets the left property of that icon to be another 5 pixels. So it would move slowly to the right. Now, this is a recursive function, which means that every time there's a new animation frame, every time like that 16 milliseconds comes around, that's going to keep calling that. So you not only get a more precise and smooth animation, which actually like looks more performant, you know, because it doesn't have any jankiness or inaccuracies with timing, but also it's going to do that work when it's actually ready to in the first place. So that's also how I can do it more performantly. So this is, obviously you've probably spotted the flaw in this code. This is going to run forever. So there is a function called cancel, I think, animation frame, where you can actually like cancel it, or you can just use the timestamp that gets passed in by requestAnimation frame to stop that once it's gone past a certain duration. I just didn't want to sort of convolute the code. I just wanted to show you a quick example of how you could make something look very 60 frames per second, but also take advantage of scheduling in the browser because it knows when the best time is to move that box for you. So a couple of extra tips, because requestAnimation frame actually comes with a lot of caveats. I'm going to be sharing a post by Paul Irish in my resources, but some of the highlights from that are stop recursive calls when they're not needed. So don't do what I did there, and once the icon has disappeared off the screen, you don't just say, oh, well, it's gone now, so it doesn't matter if it runs forever. That's not true. It's still doing work, so stop that work when you don't need to, even if it is very performant. Avoid excessive stacking of requestAnimation frame. So every call to requestAnimation frame you make within a requestAnimation frame callback, kind of like what I was doing before, that queues up work for the next frame. So if you have lots of kind of unrelated requestAnimation frame callbacks running, it's going to stack up a lot of work for the next frame, because as soon as you call that, it's guaranteed to run in that next frame. So if you have like 5 or 6 of these individual callbacks throughout your code, that's going to create a lot of work for the browser to do. So it doesn't matter if it kicks off that work on time. It could end up making that frame take way longer than 16 milliseconds because you haven't been smart about when you're actually scheduling it. So just watch out for that. That can be a caveat. And again, if you'd like more detail on that, I have a blog post for you to read later. Also, watch out for that same layout paint cycling. It's possible to be triggering layout, causing paints, and then triggering layout again in the similar way that I showed before. And if you do that in requestAnimation frame, you're losing all of the good work that you did. So just be super aware of that too. That can happen a lot when you're computing things like parallax, sort of like effects when you scroll and things kind of move based on the scroll. It's very common for you to accidentally get in this like layout cycling and paint cycling stuff. So there are some really, really good resources from the Chrome developer folks that have blogged endlessly about how to stop these kind of bottlenecks happening. So I'm going to share those links too. Another thing that you can do is to debounce and throttle frequent input events. So things like click events, unless someone's really, really enthusiastic on your site and they're just hitting that mouse button like a million times a second, unless it's a game where they're trying to shoot something really quickly, you generally don't really have a lot of really expensive input events happening with clicks unless you've chosen to do something pretty poor with your JavaScript. But there are other events that fire very, very quickly and in rapid succession. And so a couple of examples of that are scroll, mouse move, window resize. Like every time you keep dragging that window, it's just firing constant events reporting that. So be very, very careful about the kind of code you run in these event listener callbacks or event listener handles, because that can get out of control really quickly. We have some really good tools and libraries, not natively in JavaScript necessarily, but in libraries that we can use to get around this. And what I would suggest you do is to debounce and throttle. So for example, a window.onResize, unless you absolutely need your code to run every time there's a minute resize of the window, try not to do that. Even just like debouncing it to 100 milliseconds, which means it will wait to see if the user is still resizing it after 100 milliseconds, that can really, really help. So it can just wait until that action has been done, and then it will go and recalculate something. There are a lot of really subtle things you're calling in your JavaScript that the user is not going to notice this, for example, especially when it comes to like tracking events, which are completely invisible to them. But if you're not handling them properly, you can be sending them into Jank, and they have no idea what's happening. The second example is like on an on-scroll event, maybe you want to be reporting back to your tracking analytics software like, oh, the user scrolled all the way down to the bottom of the article, or the user scrolled X amount down before like leaving the page, or they stopped for like X amount of time after scrolling. Definitely throttle them too. And again, like 100 milliseconds is actually not that conservative. Like you could probably like push that out more. And the send tracking event could be doing something such as pushing an event onto a stack of events. And then you could probably just wait until you know, the actual like browser page is idle, maybe they're reading something. That's when you can actually start batching them off and sending off those tracking events. But while it's scrolling, you can absolutely collect those scrolling events, but just be really, really careful and try not to collect them on every single event firing, because that's when you're going to see page tearing where the actual browser can't keep rendering the next content they're trying to get to because it's just so locked up, like trying to do all the stuff that you're asking it to. So that's another thing you'll see a lot probably on your mobile when you're trying to scroll down a news article and the page is completely blank. And you're like, what is happening? And it's because it's locking up your thing and you can't actually see anything. So I've talked about all this stuff you can do, and I've alluded to profiling and things like that, but you know, how do you actually measure this stuff in the first place? I don't really have time tonight to show you the comprehensive view, and you saw a screen grab that I showed of like that evaluation time happening, which was very, very insightful. But the three major browsers that are used are like Edge, Firefox, and Chrome. They all have super awesome performance DevTools baked in. They're all extremely similar to each other. So the Edge DevTools, you can go to aka.ms/perfdevtools, and there is a complete walkthrough of how you can profile your site, what things to look for, what kind of features there are in it. And so you can see here, it will give you a UI thread summary, which will tell you what it did, like how much it did of what during that UI thread, which is pretty cool. So you can kind of see where your bottlenecks are. Like, do I have too many paints? Am I recalculating my styles too often and things like that? Similarly, the Chrome DevTools, which you can get at the address there, they have a very similar thing. You can see here that they're showing you when you're scripting, rendering, painting, other, and idle. So that's a very, very similar point of view that you can get. I really do think that most of the profilers show exactly the same information, just in a slightly different way. So If you're having a particular issue with one specific browser, which these days doesn't happen anywhere near as often as it did, you can actually get the same information from each one. So if one's being particularly problematic, then you can use that. And in Firefox, it's in the Firefox DevTools, and you can go to your developer.mozilla.org address, and the performance tool is documented very heavily in there too. So it shows you all sorts of things like, you can see here, there's like fire charts of what was happening when, so you can spot those bottlenecks. And honestly, like the documentation of each is going to tell you how to use it way more effectively than what I can show you today. I know that every time I've seen someone on stage zoom into a flame chart and start clicking around, I'm just like, I lose context really quickly of that. So I would encourage you to just have a play with that yourself. So what kind of stuff is coming down the pipe to help us with future stuff, and what current stuff is difficult to use but should get easier in the future as well? There's only a couple of things I'm going to cover here. One of them is request idle callback. Has anyone heard of that coming soon? Yep. It's been in spec for a long time. I do apologize on behalf of the company I work for. Edge is currently under consideration to include it, so is Safari. I know that I checked today, and Edge has assigned it medium priority, which means it will probably most likely get done. Please don't quote me, don't come after me if it doesn't, but generally that's what medium priority means. So it is still under consideration, but it's probably coming eventually. And I'm not sure about Safari. I don't really have any contacts there, so I couldn't find out for you. But what request idle callback does is it's similar to requestAnimation frame, but you can use it for things other than animation. It's a little bit more powerful for just the everyday JavaScript you're doing. You can essentially say, like, when there is idle time in that frame. So if I have a particularly empty frame where it wasn't really doing anything, a lot of the time that's when the user's not scrolling and they're just reading the article and you're not making any AJAX calls or anything like that, which are actually in a different thread, but still. If there is that little bit of space at the end of the frame, it will actually call your handler. It will tell you what the deadline is. It'll tell you how much time you have. And then you can take that and decide how much work you're actually going to do, which is pretty awesome. So you can get that handler and decide, oh, do I have enough time to complete this like weird thing where I'm going to adjust all the paragraphs? And if you don't have enough time, you can do some of it and then request another idle callback and complete that work. And so to me, that's really exciting because you have a little bit more control and it gives you insight into what your frame is doing when. So I would definitely encourage you to research request idle callback online. There's already polyfills, which don't do a perfect job because they use set timeout, but you can actually start playing with the polyfills so that you can think about how you might actually start using this in production, which is super, super cool. Is anyone currently using request idle callback in production? Nice. I want to talk to you later about your use cases. That'd be awesome. Comlink. Who's heard of Comlink? Awesome. Okay, a couple. This is a project that was started by Surma, who works on the Chrome Dev Advocacy team. He's trying to make web workers just a little less robotic to work with. So I didn't get time to cover web workers in this talk, but web workers are a really great way to move work off into a separate script that is not running in the main UI thread. So if you have anything really expensive, such as like a massive like multi-dimensional array set, for example, that you're trying to like compute things on, you might be in a job interview and you're trying to rotate that matrix array. If you're just trying to do anything expensive that can lock up the UI thread, you should absolutely put that in a script. Now, there's a few caveats to web workers. The first one is that you have to use this kind of technique to communicate from the main thread and back again, and it's called post message. So you kind of have to send it data over, and then it has to send it back to you when it's done. And it's almost this like walkie-talkie relay system, which is a bit strange. And you can't send massive amounts of data over because then you lose that performance gain by having to like lose that in the actual like, I forget what the term is called, but you lose that time through trying to like move it across the, what is it, the barrier, translation barrier or something. You lose that. Now we did for a while have shared array buffers, which were amazing. You can actually dedicate memory for the main UI thread and the web worker to actually manipulate read from update. And then Meltdown Inspector happened, which was actually really sad. So shared array buffers right now are disabled in all major browsers because they can encourage naughty things with those two processor hacks, and I won't go into too much detail, but it's about being able to use them as precision timers, very, very high precision timers. So web workers is sort of not just because of Meltdown Inspector kind of ruining the whole like data sharing thing, but they're not really used as much as people expected them to be in production, but they do save you a lot of time, but they are very clunky to use. So you've probably spent some of your time ignoring what I'm saying and reading this description, but Soma is trying to make a library where you can essentially use Comlink you give it your actual web worker script, and instead of having to do post messages, it does that on your behalf. So you can treat that web worker as if it's just a native library that you imported or you included as a script tag on your page, and you can just call methods on it as long as you're exposing the right thing in that web worker, which I think is really awesome. So in this case, it's a very simple case where there is a web worker that has a function called log something that's attached to a class, and then you can instantiate an instance of that class and call it as if it was just existing in your code instead of having to do a post message and ask it to actually do that with strings, which is very strange. So I think that's really cool. I have actually tried this out, and for my needs, it was a little too slow in transferring that data over still because, like, sad face, we can't use shared array buffers. So I'm still trying to think of something that I can use where I don't have to shelve large amounts of data over to it in order for me to take advantage of this. So again, if you've used Comlink or if you use web workers a lot, I want to talk to you about that. So resources, most of the stuff that I talked about today, I got from the following resources. It just made it easier for me to check my work. Again, I haven't been a front-end developer for about a year now, so I needed to make sure that everything was still relevant. Jankfree.org literally splits up each thing I talked about today in more detail. So if you want to know in detail what does repaint mean, what is triggering layout or reflow, what about events, and why would I have bottlenecks in events, Jankfree splits all of those things up into different sections and shares videos, links, and articles and things like that for each particular section. I found it super awesome, and there's some really good talks in there as well as case studies. I think some of the highest value things on jankfree.org are the case studies of how Pinterest became more performant by the things that they did, for example. Chrome Dev Perf Guide, that's where a lot of the request animation frame info that I gave today came from. Paul Irish's request animation frame scheduling for nerds is one of my favorite articles I've read on request animation frame. It talks about like how those bottlenecks happen. It talks about when each frame gets queued up and things like that. And it actually shows you that kind of time series of it as well, which I think is really cool. Nolan Lawson, who's a colleague of mine, he did a really great talk recently called Web Performance in the Real World, where he talks about it from a browser perspective. So having that insight from the browser vendor itself can be really useful to kind of see like the problems and challenges they go through and how we can actually write better code that helps everybody out. And recently I saw a talk by Tom Dale. He's one of my favorite speakers like ever. He has this way of making the audience feel smart, and it's like a golden skill of public speaking. But he's been speaking at a few conferences, including ReactiveConf, which is the link I put up. It's called Secrets of the Glimmer VM. This is kind of a futuristic take that he's actually using in Glimmer these days on where web performance might actually be going. So he's using things like bytecode and hopefully the future of WebAssembly in order to make the template compilation and template updating in single-page applications much, much faster. And so we all know in front-end that there's a performance race to the bottom between all of the different single-page frameworks and view frameworks, and Glimmer is no different. And so I think that Tom Dale's thinking about bytecode is actually like very forward-thinking and will work very, very well once WebAssembly becomes much more readily supported in browsers. So that was a fascinating talk. He lays it out in a very understandable way. So I would highly recommend that you check out all of these resources because they got me really, really excited about WebPerf. And that's all. Thank you.